Alright everyone, we are now in section 9.5, which is our very last section, and this is called the binomial theorem. It is a quick and easy way to expand a binomial raised to a power. So let's try it here with x plus 3 to the fourth power. So you can use the formula with the combinations. I feel like for a small exponent like 4, it's probably easier to use Pascal's triangle. So you can replicate that pretty easily. It starts with a 1, and then 2 ones. You go left and right. And now, if there's a number in between 2, you add. Right? So 1, 3, 3, 1. So this is for 0, 1, 2, 3. So now we're on 4. 1, 4, 6, 4, 1. So this is the numbers that we need as our factors in front of our terms. So all you do to make this is you add terms to get the number underneath it. So that's kind of a little tool called Pascal's triangle you can use. So I'm going to use 1, 4, 6, 4, 1 as factors. Now I'm going to just write out. I'm going to write out every single step so we can see it, what my terms look like. So first I'm going to use this number here, 1, times, then it will be x to the fourth power times 3 to the 0 power. So the two exponents here will always add up to 4 every single time. The 1 for the x's will start decreasing, and the ones for the 3 will start increasing, okay? And then we need to keep including these factors over here, the 1, 4, 6, 4, 1. So plus 4 times x cubed times 3 to the first, plus 6 times x squared times 3 squared. Oops, this should be a 3. So notice that the exponents will always add up to 4. Plus 4 times x to the first times 3 cubed, plus 1 times x to the 0 plus 3 to the fourth. So obviously this is pretty ugly, so we can make this look nicer, look like a nice polynomial by evaluating the powers and multiplying. Okay, so 3 to the 0 is 1, so this is just x to the fourth, plus, okay, so 4 times 3, 12, x cubed, plus 3 squared is 9, 9 times 6, 54, x squared, plus 3 cubed, 27 times 4, 100 plus 8, 108, x, plus 3 to the fourth, which is 81, right? X to the 0 is just 1. So that was pretty quick. Now we're going to try the next one, which has a fifth power. Notice that the terms in the binomial have exponents as well. So this might be a little bit more work. And then also we have a negative term in here, which means that our terms are going to alternate in sign, right? Sometimes we'll have positive terms, and then other times we'll have negative terms. So first we need to figure out the next row of Pascal's triangle. I'll just continue writing it over here. So 1, 5, 10, 10, 5, 1. So this will be raising a binomial to the fifth power. So these are our factors we need for every single one of our terms. These will just give us the coefficients, I believe, since we don't have any coefficients inside the binomial, except for negative 1. Okay, so let's start writing it out. So I have 1 times x squared to the fifth times, negative y squared to the 0. So don't forget the sign. The sign will help you to determine the sign of each term as you simplify this. Plus 5 times x squared to the fourth times negative y squared to the first. So you can already see this term will be a negative term. Negative y squared to the first power is negative, so that's going to be the first negative term of our polynomial. Plus 10 times x squared cubed times negative y squared squared, plus 10 times x squared squared times negative y squared cubed, plus 5 times x squared to the first times negative y squared to the fourth. I almost fit it. Last one, plus 1 times x squared to the 0 times negative y squared to the fifth power. So notice the same thing as above. The exponents always add up to 5. 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. I'm bringing that up because the formula looks a bit scary, but this is pretty much what it's saying. Okay, so now we can go ahead and simplify our terms here. So remember that when you have a power to a power, you multiply the exponent. So this is x to the 10th. Okay, the next one is going to be negative because that negative y squared to the first. So negative 5 x to the 8th y squared. The next one has an even exponent, so plus 10 x to, where are we at? The 6th y to the 4th. Then the next one will be negative because of the odd exponent. Negative 10 x to the 4th y to the 6th. So I'm multiplying these exponents still. The next one is positive, plus 5 x squared y to the 8th. And the last one again is negative. X squared to the 0 is 1. Y squared to the 5th is y to the 10th. Okay, so the more you practice with that, the more you'll kind of remember it. It will be useful later in your math classes to come. Let's say you weren't interested in a specific sort of the entire polynomial, but you wanted to just know a term, especially if the polynomial is quite large. So we have a formula for that. Notice that this one you do have to use a combination. So that's this notation here, and you can use it on the calculator. You just need to find the NCR button on your calculator. I can show you how to do that as well. Okay, so find the following. The sixth term in the expansion of 3x plus 2 to the 8th. So the sixth term, well, what power will that be? So to use this formula, we need to know the power of x. So the sixth term, well, the first term will be x to the 8th, 7th, then 6th, 5th, 4th, 3rd, 1, 2, 3, 4, 5, 6. So we want to know the x cubed term. So in terms of the formula, this means that j is equal to 3. Okay, and then n is right here. N is equal to 8. So we can go ahead and just apply these into the formula. So it's going to be 8 choose, that's n minus j, 8 choose 5 times a, okay, that's the second term, 2 to the n minus j, so 5 times x, so the variable term, the first term, 3x, to the third, j power. So in order to do 8 choose 5, we need to find that NCR function on your calculator. I can include a page about that in Canvas. I'm just going to type it into my calculator now. 8 choose 5 is 56. 2 to the 5th is 32. 3 cubed is 27. And then x cubed is x cubed. So 56 times 32 times 27. So that term is 48,384 times x cubed. Okay, one more. The coefficient of x squared in 2x minus 3 to the 9th. So this time they gave us the j. J is 2, and we have n here. I think it'll be easier to find the entire term, and then we can reference back and give the coefficient. So it's going to be n choose n minus j, so 9 choose 7, times the second term, which is negative 3. Be sure to include the sign, to the n minus j power, so the 7th power, times the first term, 2x, to the j power, which is 2. Okay, so get 9 choose 7, 9 choose 7, that is 36. Negative 3 to the 7th power is negative 2,187. 2 squared is 4, x squared is x squared. So I have 36 times 2,187 times 4, so that is going to be negative 3,14928x squared. So the coefficient, which is all we were really being asked for, is just that constant multiple in the front. So negative 314,928.